Hi Chem students, welcome to a lesson over dimensional analysis. So what is dimensional analysis? It's an important method of solving mathematical problems requiring unit conversions. Do not attempt to do these problems using your own method. We are in training and you will have to be able to solve problems using this specific technique, so learn how to do it now. Every dimensional analysis problem contains three major parts. You're going to have the unknown, the given, and conversion factors. So what are conversion factors? They're ratios that relate two amounts that are equal. This word equal is very important. For example, suppose you want to know how many quarters there are in $10. To figure out the answer, you need to know how quarters and dollars are related. As we know, there are 4 quarters per dollar and $1 for every 4 quarters. Those facts can be expressed as ratios. So if you look, I have these ratios written here. That's what conversion factors actually look like. In a conversion factor, the top part equals the bottom part. In other words, a conversion factor is always equal to 1. When you divide something by another quantity that is equal to it, it's like dividing that number by itself, which always equals 1. We use conversion factors as a way of converting between different units of measurement. Since conversion factors have a value of 1, when you multiply by them, although the number and the units will change, the value stays the same. In order to use a conversion factor, we need to align the units so that the units we're trying to get rid of cancel out, and we're left with the units that we're looking for. In order to cancel something out, you do the opposite operation. For example, if the unit that we want to cancel is on top, we put it on the bottom in the conversion factor so that the unit cancels out and the new unit will be on top. So if you look at my dominoes here, I've aligned them accordingly. You start with your given. It's our top unit. If I want this to cancel, then I need the same unit on the bottom. Why? Because they will cancel out. And then what we're left with is our new unit on top. So let's go back to our example about quarters and dollars. So the original question was how many quarters are in $10 if 4 quarters equal $1? Well, like I said, every dimensional analysis problem has 3 parts. We need to identify the given and the unknown first. So the given is always going to have a numeric value. So $10 is our given. It's the quantity that we're starting with or trying to convert. Our unknown is what the question's asking us to solve for. So the question's asking us to solve for quarters. This is the unknown. And then lastly, we'll have the conversion factor. Sometimes it's given in the problem, sometimes it's not. So 4 quarters are equal to $1. These are our conversion factors. So as we saw before, there's 2 ways to express these conversion factors. You can have the $1 on top and the 4 quarters on bottom, or vice versa. You can have the 4 quarters on top or the $1 on bottom. Well, when you set this up in dimensional analysis, it does matter which way the conversion factor goes because we need to cancel the unit of the given. So let's look at the setup. You always start with the given, so I'm starting with my $10. Since that's the unit that I want to cancel, I need dollars to go on bottom. This first conversion factor does not have dollars on bottom. It has quarters. So dollars wouldn't cancel. We would end up with dollars squared in the end. So I need to choose this conversion factor where 4 quarters are on top and the $1 is on bottom, so that my units cancel. So realize that units are going to cancel diagonally. Then to get my final answer, you'll multiply across the top. So I've got 40 quarters as my final answer. On bottom, I have the number 1 if I multiply across the bottom. So as we know, 40 over 1 is just 40, and my final answer is 40 quarters. So let's go over what we did step by step. Both 4 quarters and $1 are the same amount of money. So multiplying by this conversion factor does not change the value of the money. However, the units are different after using the conversion factor. Cross out the dollars because they cancel, and you're left with quarters for the unit of your answer. And we have to be left with quarters. We need our unit in our answer to match the unit of our unknown. Sometimes dimensional analysis problems will require multiple steps. So here's another example. You're throwing a pizza party for 15 people and figure each person might eat 4 slices. You call up the pizza place and learn that each pizza will cost you $14.78 and will be cut into 12 slices. How much is the pizza going to cost you? Okay, remember, you want to start by identifying the 3 pieces of a dimensional analysis problem. Let's start with the given. What do I know? I know that 15 people are going to be invited. This is my given. Now I want to figure out the unknown, which is how much is the pizza going to cost? So we know that our unknown needs to be in dollars. Then we know we have conversion factors relating these 2 units to each other, the given to the unknown. And like I said, sometimes it's going to take several steps. So in this problem, they're giving me those conversion factors. It says that you figure each person might eat 4 slices. So 1 person is equal to 4 slices. You call up the pizza place and learn that each pizza will cost you $14.78. So 1 pizza equals $14.78. You also find out that this pizza will be cut into 12 slices. So 1 pizza is going to equal 12 slices. You may already see how all of these are going to be related. Remember, to start your dimensional analysis problem, you want to start with the given. So 15 people. And I'm going to use these 3 conversion factors until I cancel all the units, but I need to solve for dollars because I'm trying to figure out how much is this going to cost. So first, I need to cancel people. Well, the only conversion factor that includes people is 1 person equals 4 slices. The 1 person must go on the bottom, and the 4 slices must go on top. Why? Because I need people or person, human beings, to cancel. The next conversion factor I'm going to choose is going to cancel out slices for me. So it's got to be this one. My 12 slices must go on bottom, so slices cancel, and the 1 pizza is going to go on top. Slices cancel. So if I solved and stopped right here, I would figure out how many pizzas I needed to order. But that's not the question. It's asking how much it's going to cost. So I need to use that last conversion factor. 1 pizza goes on the bottom for $14.78. Pizzas cancel, and lo and behold, I'll be left with dollars. It's important to note that the numbers aren't going to cancel, okay? Just the units. So what I'm going to do is multiply across the top. So I will multiply 15 times 4 times 1 times 1478, and I'll get the numerator. Then I'll multiply everything on the bottom. 1 times 12 times 1. And I will get the denominator. So when I do that, my numerator is $886.8. And then on bottom, I have 12. So you multiply everything across the top and then multiply everything on the bottom and divide so that I get my final answer, which is $73.90. So like I said, a lot of dimensional analysis problems will be multiple steps. It's not going to be as simple as that first example. Another thing that's important to note is sig figs. So yes, I taught you sig figs in the last video. In this example, because everything is exact, we have infinite sig figs. So my answer can have an infinite number of sig figs as well. For example 3, I want you to try this one on your own. It says how many seconds are in a day? So go ahead and pause the video, take some time to process what you just learned, and solve your answer. We'll go over this together tomorrow. Deriving conversion factors. You can derive conversion factors if you know the relationship between the unit you have and the unit you want. For example, we now know that 1 meter is equal to 10 decimeters, so you can write the following conversion factors relating meters and decimeters. You can then use these metric conversion factors and dimensional analysis to solve problems concerning measurement. Example 1. How many milliliters are in 4.56 liters of solution? So I'm going to identify my given and my unknown. The given, remember, always has a number. So the given is 4.56 liters. The unknown is how many milliliters. The only missing part is the conversion factor. Notice it's not given here because in my mind, I'm supposed to already know these. So I'm going to write out my King Henry scale. King Henry danced before drinking chocolate milk. These are my prefixes. Remembering that the base units are meters, liters, and grams. So I need to figure out my conversion factor, which is how liters and milliliters are related. So remembering from the last video, here is a liter. It's my base unit. I'm converting to milli. So the larger unit, the one furthest to the left, always gets the 1. So it's 1 liter equals, it's over 1, 2, 3 spaces, 1,000 milliliters. The 3 zeros corresponding with the 3 places you had to move over on the scale. So now I have my conversion factors. I can set up my dimensional analysis problem. We start with the given 4.56 liters of my solution. What has to go on bottom? Well, we're trying to get rid of liters. We want to know milliliters. So liters has to go on bottom. 1 liter is equal to my 1,000 milliliters. And I can solve my problem because liters are canceling. I multiply across the top and I get 4,560 milliliters. Now, sig figs are important. If I look at my given, because this is a measurement, it's liters, so we're assuming it's been measured. This is 3 significant figures. If I look at my conversion factor, this is infinite. You always round to the least amount of sig figs, which would be 3, so my answer needs 3 sig figs. This number has 3 sig figs without a decimal. If I put a decimal at the end of that 0, then it's going to be 4 sig figs. As long as you leave it 4,560 without a decimal, you're okay. Again, sometimes even metric conversions can be multiple steps. So let's try one of those. How many kilograms are in 4,500,000 milligrams? Well, this is my given. This is my unknown. I need a way to relate these. So here's my scale. Remember my base units, meters, liters, and grams. Well, the biggest unit gets the 1, which is kilo. So 1 kilogram is going to be equal to, I want to go all the way to milli, which is all the way across the scale. What you need to realize is you have to stop at the base. When you're doing conversion factors, you have to stop at the base unit. So the base unit is 1, 2, 3 over. So that's 1,000 grams equals 1 kilogram. Well, I need to go on to milli. So for every 1 gram, this is going to equal 1, 2, 3 places over. So it's 1,000 milligrams. So I have 2 conversion factors that I'm going to have to use. Let's set up our dimensional analysis problem. Starting with 4,500,000 milligrams. Now I'm going to need 2 conversion factors. I need to cancel milligrams. So my 1,000 milligrams goes on bottom, my 1 gram goes on top. Milligrams canceled. If I stopped here, my answer would be in grams. That's not what I want. I want kilograms. That's the unit of my unknown. So on the bottom, I'm going to put 1,000 grams. On top, I'm going to have 1 kilogram, and they cancel. So you can see, using dimensional analysis keeps everything kind of nice and pretty, and everything's taken into account. So again, I'm going to multiply across the top. So 4,500,000 times 1 gives me 4,500,000. Divided by multiplying my denominators, which will give me 1 million. Put this in my calculator and it gives me 4.5 kilograms. Again, round to sig figs. So if I look at my given, this has 2 sig figs. There's no decimal, so only the 4 and the 5 are significant. Again, most of the time your conversion factors, they are going to be infinite. So I'm rounding to the least sig figs. My answer needs 2 sig figs. Perfect. Final answer, 4.5 kilograms. Example 3 reads, how many kilometers are in 587,000 meters? I want you to try this one on your own. Do it in your notes, pause the video, and we'll go over it tomorrow. I hope you found this video over dimensional analysis to be helpful. If you need more help, watch the video again or seek Chapter 2 in your textbook for more resources. I'll see you in class tomorrow for more practice.